For chemist Lee Cronin, chemistry is all about discovery. And despite methods and techniques that have developed leaps and bounds over the centuries, for Lee, the process of discovery is still all about the journey.
It's very difficult when you ask a chemist in the lab to go discover something. It's a bit like asking someone to go in a boat now and find a new continent. Something invariably goes wrong and more interesting happens, and then we follow that up, and I think that is the point where conventionally a lot of discoveries are made today.
But despite his love of the voyage, Lee thinks it's time to change up the process. Not the aspect that relies on some magical combination of luck and intuition, but exactly how the search is carried out. Lee wants to automate the quest for new reactions. Machines already exist to automate certain tasks in chemistry, but they tend to follow specific programming and recipes rather than searching for new discoveries. There have also been attempts to aid discovery with machine learning, where a computer is trained with data and learns how reactions might operate. Lee wanted to make a machine that could learn and carry out tasks. I called him up to find out more.
So what we've tried to do is use machine learning to classify whether the outcome of a reaction, that is when you mix two chemicals together, is whether something has happened or not. And then you can use that as a basis to then, navigate around, if you like, your new chemical space, or sail your yacht around your unknown islands and map them.
And your machine isn't just learning, it's doing experiments.
Yeah, we do three crucially important things. Number one, we start with an empty database, except just it knows the ingredients that we have at our disposal. Number two, it just randomly selects the ingredients, the chemicals to add together, so it has no bias. And number three, it does this in real time. So it actually decides what to do and then mixes the chemicals together and watches what happens.
When we say it in these sentences, we're actually talking about a robot. Can you describe what this robot is? Because it's not like some kind of humanoid thing sitting at a chemistry lab table, right?
No, but actually it does things very similar to what a humanoid would do or a human being would do at the chemistry lab table. And a chemist would typically mix chemicals together in a round-bottom flask and put on a stirrer and heat it up, and that's what this robot does. You plug the chemicals into the robot and it moves those chemicals as liquids in a solvent to the reactor, and then the reaction happens and then the robot automatically takes a sample and moves it to a detector. And it's basically like a human being using its eyes or your ears, so it happens really quickly and seamlessly.
So is this really a closed system? Is this doing everything, or is there still need for human input at some stage?
Oh, yeah, the human is crucial. This is not about replacing the human. So what this robot does is just a labor-saving tool. The robot is only as good as the chemist that's trained it. Well, the robot would do the experiment, and the chemist would tell the robot whether the outcome of the experiment was reactive or unreactive, so whether something happened or not. And so the robot would then start to guess after a while, and then the human would go, yep, you're right. And then that gets to a crucial point where it's done about 10% of the possible combinations. It is able to predict what will happen next, and it just speeds up our ability to discover new reactions and new molecules. Human time is limited, and so if one of the things the robot can do is basically do reactions the human doesn't have time to do and would normally discard. It can do about 36 reactions a day, and a chemist would only typically do maybe 3 or 4 such reactions a day.
We've described how the process works, but have you actually managed to find anything novel with this robot?
I'm pretty happy to say that I think I could convince maybe 9 out of 10 chemists that the robot had done some reactions where the outcome couldn't be predicted beforehand, and that's, for me, really exciting.
Robots and automated machines are already used in chemistry, in industry. Just how different is the system that you're using here from the kind of robots that might exist in other contexts in chemistry?
What's different about our system is its integration and the fact it searches for reactivity. What we're doing is actually quite unusual in that it basically is able to search without any target in mind, and then what we needed to make sure we were doing, not just having new sensors and not having any target, but actually having machine learning to actually correctly search those reagent or ingredient combinations.
What actual applications will these differences be useful for?
Oh, we're really excited because we think that this, in terms of discovery science, anything where you need new molecules, so new drugs, new dyes, drug delivery systems, new materials. Now, there's a problem when you're discovering, when you don't know what you're looking for. So the next thing that we're going to do is add another little sensor, but this sensor onto this will then have a desire and say, right, we want to find, I don't know, the bluest blue thing. So now let's not just look for new stuff, but it has to be new and blue.
And personally, what are you most excited about the opportunities that having this integrated robot system could open up?
Well, I'm hoping that what we will do is it will tell us more about the laws of chemistry and allow us to discover molecules that we just wouldn't have access to using our existing knowledge. I kind of liken a bit like to writing poetry. Shakespeare was really interesting in writing poetry and verse because he invented new words. What I'm interested in this robot, seeing what they do, is able to invent new reactions. Then those reactions can be translated back to the normal chemistry language, and then the chemist is able to use those new reactions to make new molecules. For me, that's super exciting.